Well, welcome to our second Jones Seminar of the year. Again, the theme for this term has been engineering in medicine. And so we started off with one of our own speakers last week, and this week we're drawing from a little further south. Today we're honored to have Anthony Wolbarst come to talk to us. He's Associate Professor in Division of Radiation Sciences at the College of Health Sciences at the University of Kentucky. Dr. Wolbarst is a Dartmouth alum. He did his PhD right here at Dartmouth in the physics department and has taught, after leaving Dartmouth, he taught and carried out basic research in magnetic resonance and high pressure physics at the University of Witwatersrand in Johannesburg, South Africa for 6 years. He then wound up being a NIH postdoctoral fellow in medical physics back here and worked at the Harvard Medical School on the faculty for 3 years. After that, he joined the National Cancer Institute at the National Institutes of Health and worked in medical physics there. He's certified in the American Board of Radiology in the fields of radiological physics, medical nuclear physics, and therapeutic radiological physics. He has a very fascinating biosketch, really. In 1986, he moved from the NIH over to the Environmental Protection Agency in the Office of Radiation Programs. He was senior scientific advisor and led the group that provided scientific technical analysis and the support of the agency's development for the national standards for the cleanup of contaminated radiation sites. For that, he received an award, Vice Presidential Award for National Performance Review Award in 1999. He has edited several books. He's editor of Environment in Peril, a Smithsonian Press book, which was based on seminar series he had at the EPA from people as David Bauer, Jacques Cousteau, John Kenneth Galbraith, Jane Goodall, Ralph Nader, Carl Sagan, Ted Turner, and others who he brought in to speak at the EPA. He then followed that up with a book called Solutions for Environmental Peril. So hopefully there are some solutions. He had a 9-month detail at the EPA's Office of Policy, where he published a model on global warming in the American Journal of Physics. And all that time he maintained an adjunct appointment at the Georgetown University. He has written 2 textbooks, Symmetry and Quantum Systems is one, An Introduction to Group Representation, and a general public book, Looking Within, X-ray, CT, MRI, and ultrasound. And so today he's going to be talking about medical imaging and his work in that area. He actually has published the textbook we're using for a graduate medical imaging class called The Physics of Radiology, and he has now started a publication every 2 years called Advances in Medical Physics. So he's certainly at the forefront of the medical imaging world, and it's a real pleasure to have him here today. Now, he's asked to do a relatively unorthodox talk, which I think will be very useful. He's going to give a 2-part talk, and I'll let him describe that to you. But so there will be the Jones Seminar part, and then for those eager to listen for more, there will be sort of a second part to the talk. But please welcome Dr. Wolbarst.
Thank you, Brian. It's really a great pleasure to be back at Dartmouth. I always love coming here. I spent 4 of the happiest years of my life here, and that was largely because I had the extraordinary fortune of having a remarkable man as my thesis advisor, Bill Doyle, who was chairman of the department at that time. He's sitting up in the front row, feeling a little bit embarrassed about this. But Bill was an outstanding scientist, is an outstanding scientist and teacher, and at the same time, and even more importantly for me, he was a splendid example of what it is to lead a life of decency and integrity and kindness. And Bill, I thank you again. A woman, 57-year-old woman, has had headaches. And they're intermittent, they're not migraine headaches. They are interior of the right ear and behind the right eye. They come and go, and they can be taken care of with an Advil or a Tylenol. She had a comprehensive physical examination from her physician, who found nothing of any substance, nothing that would explain this. She led a normal, reasonably healthy life. She exercised, she didn't drink to excess, she didn't smoke. She wasn't stressed out, so it was kind of puzzling what these headaches were due to. So her physician suggested that she have an MRI. And I'll tell you right now that the MRI, what they was learned on the MRI, probably has nothing to do with her headaches. Any kind of medical imaging procedure is concerned largely with producing some kind of contrast between healthy tissue and unhealthy tissue. And in this particular case, a pulse sequence was chosen which emphasizes T1, which is a tissue characteristic which is central to clinical MRI. And we'll talk more about what T1 is later on. But what you can see here is a darker region which is in contrast with the surrounding areas, as well as the fact that there is a significant asymmetry between the left and the right ventricle. Now, this is on the right side. When you're looking at a CT or an MRI, you look from the feet up. So this is on her right side, and it happens to be in a rather bad place. It's in an area that processes and allows transmission of information regarding sight. A second kind of image was taken using a different pulse sequence, a technique known as FLAIR, and it tends to reduce the visibility of fluids in images. And this one gave a much clearer picture of something definitely wrong. It's a lesion measured to be about 1.5 centimeters long by 1 centimeter wide. And the neuroradiologist who examined it said that it looked like a low-grade glioma. Now, the glial cells are support cells for the most part to help nourish and maintain the neurons in your brain. Recently, in the past half year, it's been found that they actually have some information processing role as well. But the point is, gliomas range in seriousness from very severe, such as what Ted Kennedy is suffering from, to something which, in the grade 1 glioma, is something you sit and watch and hope it doesn't change. The question is, what kind of glioma is it? And also, how close is it to the centers, the optical centers, that could be damaged by any kind of radiotherapy or chemotherapy or surgery? So the first step was to produce, using MRI spectroscopy, a virtual biopsy. Now, the Nmr Resonant Frequency that we'll talk about in a couple of minutes is determined by the local magnetic field that protons in various molecules experience. Now, because the circulation of the electrons in these different molecules is different, there are slight differences in the resonant frequency, and this is known as chemical shifts. These differences are known as chemical shifts. And what has been found is by looking at the spectra of different kinds of tumors in particular, the chemical shifts indicate the presence or absence of different ones of these particular materials. And they are a relevant clinical signature. And our particular patient looked like this. You see in the upper left 3 different kinds of relevant chemicals in the brain. And right now we're looking at the tumor itself. We're looking at a couple of voxels within the tumor, and we're seeing the relative heights of these different signatures for 3 different chemicals.